Hello, everybody. I'm Jesse Roitenbert with Stratasys. Carrie and Ishmael have asked me to speak about activities we're doing at Stratasys to empower our customers and provide those that are interested in going down the path of bringing 3D printing into their classroom more details on actually how to use it. We at Stratasys over the past couple of years have seen a significant increase in the amount of people that are purchasing 3D printers. But when you increase the amount of people that are purchasing 3D printers, getting into 3D printing, creating maker spaces, labs, stuff like that, the percentage goes down to of those people that are well versed on how to use it in the manufacturing, in the CAD, in the design areas. And so we saw a void. We saw a lot of instructors purchasing or inheriting 3D printers, but didn't know how to impactfully use it in the classroom. So we took it upon ourselves to reach out to our customers. They're having amazing successes, and to ask them to share what they're doing to assist, to empower other instructors out there to get a great value out of 3D printing in their classroom. So our vision is to learn by making, so it's very project-based learning focused. I'm going to talk about education, a little bit about Stratasys, and the main focus is on our content and curriculum and what we're doing with our customers and partners to develop information out there to share. Today in education, students that graduate, or even those that are going back to school while having a job, skills are different than were needed 5 and 10 years ago. We hear it all the time about advanced manufacturing. We've definitely seen manufacturing come back, and the manufacturing jobs out there are much more skill driven. And so there's a lot more creativity, problem solving, creative thinking that's necessary in the manufacturing areas and design areas. And the companies out there are telling us, and they're asking for more problem-solving types of people. And I always talk to the first robotics groups that you see in high schools and the first tech challenge groups. Of those groups, those teams, those competitions, they work like little companies. You get some people that have skills in design, in manufacturing, but also skills in marketing, also skills in outreach. And so those types of activities, those project-based learning extracurriculars are exactly the type of activities that we see employers looking for those students. And those competitions go up the hill into college and university, whether it be a snowplow challenge or an SAE challenge. Those things are very powerful, and those are the skills that we see. And it's hands-on. It's project-based learning. Learning how to do something with your hands is key. We also see a mandate that things have to happen with a student at an early age. If we don't get these students early engaged in these STEAM and STEM activities, they're not going to be excited about it in 6th, 7th, and 8th grade, and they'll be turned off already. And so we're starting to see maker spaces, STEM labs, libraries converting to media areas where the activities are turning toward 3D design, 3D print, 3D activity. So hitting it at the early age, we talked about project-based learning. Highest paying salaries out there are for those STEM fields. And I believe it's the biggest gap in what we have today and what we will need and what's coming out. But what type of teaching and learning will develop these skills? The typical sit in a classroom, single file, listen to a lecture, that doesn't work. We're not looking for people to solve problems by looking for the bold words. There's not a lot. I haven't taken a Scantron test in my my tenure at my company And so the ways of the past of teaching have to change. Most effective is to give them the students problems and projects from real life. And we're starting to see that, where it's an open-ended project where the students get to choose, and as long as they're hitting the right areas, it's a proven fact that they're learning better than they ever learned before if the project is done properly. This is a chart that is real, and it was actually even dictated by Confucius back in the day. He talked about what he reads, he forgets; what he sees, he remembers, but what he does, he knows. And so that's the same idea of project-based learning, is once you actually engage and do this, become immersed in this project, whether it be engineering, art, animation, but you're doing it hands-on, design iterations, changes, you're not going to forget it. You're going to understand it, and you're going to be better at it. We talk about in our company about failing fast. Failing fast is a great thing. Failure is how you learn. With our technology, and when people are using right, students get to fail. They get to see that piece does not fit there, or that fan that they built, they designed and printed and tested isn't the optimal fan. So let's redesign it. We don't stop when we fail. We go back to the drawing board and make it right, and that's how you learn. I have a 6-year-old daughter. She's in Spanish immersion class. And so from the moment she gets to school to the moment she leaves, she has Spanish, and it's throughout the day. This young girl in 1 year and a couple months knows more Spanish than I do from 6 years of Spanish in high school and college. But it's because they're immersed in it. I believe that engineering and STEM and STEAM, students need to be immersed in it. And so that's where you really take it in and understand it. Here we see, we're part of a lot of different competitions, and we're enhancing every step of the way how we can affect change in education. And so presenting real world challenges from, if you see here, this is Skills USA. There's now an additive manufacturing contest as part of Skills USA. We have our own contests. We have, I'll get into a slide with more different or more competitions and contests for students with real world challenges. But it's a great way to bring something into the classroom and say, hey, this is not only a contest, but we can make it our class project, or something you get a grade on, and then on top of it, you could potentially win scholarship. Little bit about Stratasys. Our motto is we shape lives by revolutionizing the way things are made. We're everywhere from consumer products to automotive to medical to aerospace, heavy in the dental market. Education is key to us. We know that if students are 3D printing today, they're going to graduate and see the value of a 3D printer, a 3D print, 3D design, and a solution, another tool in their tool bag to get to solve the problem that they need to solve. In education, we want to empower, inspire, and prepare. And we believe a properly used 3D printer enhances a classroom, enhances a curriculum, and it enhances the engagement of a student. And at different levels, we're engaging and inspiring. As you get to higher ed, we're looking to prepare, to innovate, and then these students graduate or work with industry, and they're revolutionizing. They're revolutionizing the next jet airplane, the jet engine, the way to operate. The avenues are endless. It's truly endless. Kind of the key that I wanted to talk about is our ideas for learning and the access that we've given. Here are 4 key areas, things that we've created. A semester-long course. This was designed for college and university. We have high schools and middle schools that have downloaded it and taken sections out of it because they wanted to teach the history of manufacturing versus the history of additive manufacturing. They wanted to teach tolerances during design. There's some really good stuff in there that you can pull. We've had plenty of institutions, probably 15 to 20 so far, that actually implemented these as classes, and they've been widely recognized as successful. Obviously, it takes a good instructor, but we've laid out the format so it's really hands-on. It's really student and project-based. Number two, we've got project-based learning modules. We've leaned on our customers to say, hey, what are you doing in your classroom that is fantastic? What do you think? What would you be willing to share? Get anything from the kind of outlines of how to get your students to be creative and design a chess set. And it starts with, what is chess about? Why is this game exist? There's history on it. And then all the pieces and components in it. We've seen anything from a Star Wars chess set to a Simpsons chess set, but it's all based on what the student wants to do. And when the student's doing something that they're passionate about, their efforts are significantly higher. Earbud holder. It's the most annoying thing to reach into your gym bag or your backpack and find the knotted up earbuds. You know, there's a project out there that is focused on creating an earbud holder so that doesn't happen. These modules are, they differ in length and also in, I guess, difficulty. And so some of them are a 2-3 day project that can be done by anybody that's learning 3D CAD or design. And then there's also the 3 to 4 week project that is for advanced users. These were designed for probably 6th through 12th grade, but we know that there are colleges and universities out there using these for those that are beginning in CAD and trying things out. We own the MakerBot company, and we put out a 144-page book of ideas and projects that people are out there doing. It's something that you can download. It's online. You can go to makerbot.com and find it. And then we've got a bunch of video lessons, anything from creating a catapult to a glider. Very quick, easy videos to tell you, hey, here's the idea, this is what you should try. But it's very open-ended. And so a school or a class has the ability to go in any direction they desire based on what they want to do, how they want to do this. This is the beginning. We are continuing to work on more and more opportunities like this because we have a customer base of over probably 25,000 education institutions when you add up the MakerBot and Stratasys family, and they're all doing different things. Other things that we have out there that we've seen and that we can share, we have our annual student challenge, the Extreme Redesign Contest. This is for any student out there that wants to design something, re-engineer it, or do something in art, architecture, or jewelry. A lot of classes turn this into a class project, and they'll put them in teams of 2 or 3, and students will design something. And it has a component of presentation. You have to do a write-up. You have to say why this thing has changed, why it is good, why it is necessary. And then you have to design. You have to design an STL. A lot of our customers use this, and so we see pictures or videos of their actual printed parts. But this is open to those groups that don't have 3D printers as well. So we get STLs in. What we do is we will print the top 10 in each category. Everybody that enters will receive a T-shirt. Entry's got to be complete, so you do have to have an STL file and a presentation. But those that are in the top 10, we print out their parts. We actually, I think we've turned to sending a nice Stratasys sweater. And for the top 3 in each, or top 2 in each group, we give scholarship money, and it's significant money. Over the, I think, 12 years we've been running this contest, we're over $200,000 in scholarships given. We've recently purchased the company GrabCAD. They also do challenges. They recently did a Da Vinci challenge. They recently ended an egg drop challenge. Those challenges are opened up to everyone, all ages, not segregated to education, but more challenges that exist. And then we have a lot of case studies, a lot of use cases of how people are using our technology to impact their school, their community, their students, anything from like we talked about, FIRST Robotics, custom parts on a robot, to working with local industry and helping the local craft brewery with the specific components they need for a brew tank or a tap. So those are all on stratasys.com, and we have a section that focuses just on education. Here's the Extreme Redesign Challenge. It just launched. It'll end in, I think, mid-February. And like I said, it's judged by independent judges, and there are significant prizes. And then we have communities. We have the GrabCAD community. We have the Thingiverse community, where now on Thingiverse there are instructors posting projects, things that they're doing in the classroom with their technology to impact a classroom. It's the way that we're pushing listening to our audience, our customers, and providing more so they can be more versed in 3D printing. We do believe that 3D printing in education helps to prepare students for tomorrow, for the job skills that are necessary. I'm not saying every job out there you're going to have a 3D printer or you're going to be 3D printing everything, but it's that capability to problem solve, to look at it in a different angle, to see that I could do this additively or subtractively, which is the best avenue to go down. And you gauge that based on material properties, necessity, weight, topology. Can I build it differently because I have more technology at my fingertips? Some use cases I like to show. This is a elementary school that's using a MakerBot in their classroom. They're doing spatial learning, printing a lot of small, simple parts, but then using them to really visualize, touch, feel, and take that lesson to the next step. We have high schools that are working with NASA and creating pieces that are actually going on the International Space Station. This picture right here is actually a centrifuge that astronauts are bringing up in space. NASA found out that the astronauts would get depressed because there was no green, there was no life beyond the people out there, so they sent a plant up. The plant died, made the students the astronauts more depressed. And so this group is working on a centrifuge that actually pushes the water away from the plant, so the water that's not consumed by the plant doesn't drown the plant. Neat little experiment, and it's multiple years, and so every year there's a different group of students that are working on it. But this part is actually in the International Space Station now. You can see students actually got to go up on the bomb and common and test this stuff. So exciting thing for a high school group to do. Other things, this here is a helicopter that was created by a group of students because they were working with some firefighters and they wanted to assist with actually sending out a remote control helicopter to get a gauge of where the fire is at, where it's going, how it's doing. And so a lot of 3D printed parts, they needed it lightweight, they needed to hold a lens, and then they needed to be able to control it. So you see a lot of this in drones as well with the capability of 3D printing. It's making a significant impact. Two, this is an SAE challenge or a student launch sponsored by NASA. They're printing parts, significantly sized parts to go on a rocket. They're launching into I wouldn't say into space, but high into the atmosphere. Awesome challenge, creative ways that students are getting involved, and 3D printing is a key to it because they can make parts fast, lightweight, strong, and they don't need the ability or the knowledge of a CNC. And I'm not devaluing that knowledge, but that's a significant skill that takes 6 to 8 weeks to learn to be sufficient to run some sort of a CNC or any type of milling or equipment like that. And so the 3D printers, that shortcut of if the plastic part is okay, I can print it, and I don't need to know how to direct the printer to do what it has to do. I just need to be able to design. And we do believe that this is fostering career readiness. Like I said, engaging, problem solving, looking at what you have in front of you, making changes on the fly, design iteration. You don't stop because it didn't work. You redesign and you redo. With that, I've hit a point in my presentation where I would love to take any questions, or if you have any comments. I hope this was of value. This is just the tip of the iceberg. We've got a lot of stuff in the works that we're waiting for final approval that will be launched. So there is more content, more curriculums, and then we're working with a lot of different partners to ensure that this fosters and grows. Thank you, everybody, for attending. Need anything? My name, once again, is Jesse Roitenbert with Stratasys, and you can reach me at jroitenberg, ROITENBERG, at Stratasys, STRATASYS.com.